Hello viewers, welcome to this video. In this video, we will be looking at how to use a private Docker registry in your Kubernetes cluster. Say for example, in your Kubernetes cluster, you want to pull image from your private Docker registry, which is protected by basic authentication. How would you specify the username and password and so on? Alright, so for this demo, what we will be doing is I'll be running a private Docker registry on my host machine. And inside the Kubernetes cluster, I'll show you how to use this Docker registry. We will create a simple Docker file and push our image, build and tag our image, and push our image to our private Docker registry. And then inside the Kubernetes cluster, we will try and create a pod or a deployment pulling this image from a private Docker registry. So that's plain simple Docker registry running on HTTP, no SSL or TLS or no basic authentication. So that will be our first first test. And then I'll show you how to create certificates and how to secure your Docker registry so that the connection between your Docker registry and any machine doing the Docker pull or Docker push command, the communication is encrypted using TLS, transport layer security. So we'll be creating self-signed certificates, and then we will update our Docker Compose file and then run this Docker registry with SSL or TLS enabled. And that will be our second testing. Okay, and the third testing we'll be doing is enable basic authentication. So in order to pull image or in order to push image to our private Docker registry, we need to pass in a username and password. And how we will do that within our Kubernetes cluster if we want to deploy a pod that pulls an image from this Docker registry, which is password protected. How would you go about doing that? So those are the three scenarios we'll be testing in this video. And one more thing, when we encrypt and when we enable TLS in our private Docker registry, we'll be using self-signed certificates. So any client machine doing the Docker pull won't be able to, will throw some error basically that the certificates are not valid or something. So for that, you need to add a configuration, Docker daemon configuration. So there is a Docker daemon configuration where you can add insecure registries. So saying you can specify, so this is the Docker registry that has a self-signed certificate. So please ignore any warning. So that's the insecure registries. We need to do that on the machines that we run, we use to pull the images. So basically our worker nodes. We will see all these in action now. So okay, so now let me show you my Docker Compose file. So I've created Docker Compose files. I've created a GitHub repository. Let me log into my let me show my GitHub repository. No. Okay, so github.com/justme and open source Docker. I'll put a link to this GitHub repository in this video's description. So I just created this repository yesterday. So there is this docs directory where it says docker config for insecure registry. Basically, you have to edit the etc docker daemon.json and add the insecure registries. Whatever the IP address your Docker registry is running and the port, usually it will be 5000. And if I go to Docker Compose files, Docker registry. So I have these three Docker Compose files. One is a plain HTTP. Without any security. The second one, as I mentioned, with TLS enabled, and the third Docker Compose file will have the TLS and the basic authentication. Let's see how to do all these. So first I'm going to go with the plain HTTP YAML file. It's a simple Docker Compose file. We are using the registry the second version, and we are exposing the port 5000. And we're creating a Docker registry data volume called Docker registry data, so that even if you restart your Docker container, the varlib registry directory is backed up, is persisted as a Docker volume. So that's a very simple Docker Compose file. Let's see how to run a container from this Docker Compose. Okay, let me launch my terminal, and I'm going to git clone my Docker registry here, Docker repository, git clone git just mean open source Docker. Alright, so cd to Docker cd to docker compose files, cd to docker registry. So we have our docker compose file. So first I'm going to move plain HTML to docker compose.yaml, so I don't have to pass the -f option to docker compose. So by default, if you don't specify, it will look for a file called docker compose.yaml. So first we are looking at this particular docker compose. So let's do docker compose up -d. So that's going to create a Docker container based on this docker compose file. Alright, so that's done. Let's look at the processes. Docker compose ps. Yep, so that's running on port 5000. Docker compose ps. So that's our Docker, that's our private Docker registry running on port 5000 on my local host machine. Cool. Okay, so now what I'm going to do is I'm going to create a very simple Docker file and push the Docker, build that image and push it to my local Docker registry and then use it in Kubernetes. Okay, so vi docker file, let's say from, let's grab a base image from, let's say Debian latest maintainer. No, we don't need that. Just say command tail -f dev null. Okay, that's a very simple Docker file, just grabbing the Debian base image and then I'm running the command tail -f dev null. Okay, so that's our Docker file. Now I'm going to build docker build -t tag localhost :5000 / my Debian. Let's call it my Debian version 1 and dot. Okay. All right, so that's built. So now let's push this image. Docker push localhost :5000 / my Debian v1. All right, so now it's pushing. The push refers to the repository localhost. We are pushing this image to our local repository. And if I do docker images localhost :5000 / my Debian. Yep, so that's our image. So we created a Docker file, we built the image, Docker container image, and then we pushed it to our local Docker registry. Okay, so now let's try and run this container. Docker run --name my Debian. It's just the name -it -rm, and the container name is localhost :5000 / my Debian v1 and run the bash command. Cool, so we are inside our container. Cool, so that's working fine. So that's running the Docker container locally on my host machine. So what if I were to run it inside Kubernetes? Will it work? Let's see. Because this Docker compose, this Docker registry is a plain Docker registry with HTTP with the, we haven't enabled the SSL, so it's going to error out. Let me show you what happens. So I've got my Kubernetes cluster and it's version 1.16.3. Let's deploy that file. Okay, so my IP address is 192.168.1.81. So that's my IP address of the host machine where I'm running the Docker private registry. So here, if I do kubectl get events -w. Okay, let's watch what's going on in the background. And now I'm going to run kubectl run my test -image is 192.168.1.81 :5000 / my Debian v1. Okay, that's created. But if you see here, HTTP server gave HTTP response to HTTPS client. So that's the error you will normally get. So error image pull, and if I do kubectl get all. So image pull backup, so it's having some problem pulling the image from my private Docker registry, and you can see the error here, error response from the daemon. So it's trying to connect to my host machine on port 5000, but it's saying some error. It responds to HTTPS client. So that's where you need to enable the insecure registry. So let's delete this deployment. kubectl delete deploy my test. And now I'm going to log into each of my worker node. SSH root at kworker1, enter the password, and I'm going to edit the file via etc docker daemon.json. Yeah, that's right. And here I'm going to add insecure registries, yeah, colon, it's a list. You can add multiple Docker registries here. So in my case, it's 192.168.1.81 colon 5000. That's it. Save that file and then systemctl restart docker. That's done. So we need to do that on the other worker node. Vi etc docker daemon.json and add insecure registries, and it's a list 192.168.1.81 colon 5000. Save and restart docker daemon. Systemctl restart docker service. Cool, that's done. kubectl get events -w. So now if I watch, and let's try and run the same command, kubectl run my test, and the image is from my private Docker registry my debian colon v1. That's done, and you can see successfully assigned pulling image, and it's pulled the image. Fine, cool. kubectl get all, and it's running my test. My Docker container is actually running. So that's the image from my private Docker registry. And if I do kubectl exec -it my test and bash, so now I'm inside the container and I'm running this container inside the Kubernetes cluster that has downloaded the image from my private Docker registry. So that's it. So nothing fancy about it. So that's quite simple. So now what we are going to do is docker volume ls. Yep, so that's the Docker volume that got created. We've already pushed the image into this Docker volume. So if I were to stop or restart this Docker container, docker ps, so our Docker registry is running on port 5000, and if I stop or restart this Docker container, so there is this volume here, so all the data will be in the Docker volume, so you don't have to worry about losing your data. Alright, cool. So now I'm going to stop this Docker container, docker compose down. So it's taking down everything, docker volume ls, but the volume is still there. So now let's check the number 2 with tls.yaml. So let's see what's in the docker compose file. 02 with tls.yaml. It's basically again the same Docker compose file. So now we are enabling TLS. So for that we need to generate a certificate and key pair, and then we need to use this Docker compose file to start the Docker container. So basically we'll be generating our certificates and then storing it in the certs directory, and we are mounting that certs directory inside the container under /certs, and we pass in a couple of environment variable where the key is and where the certificate is and so on. So again, it's simple. These are the only differences. So mounting the certs directory and then adding a couple of environment variables and then generating your certificates. That's it. Let's do that. So there's a documentation I've got on how to generate your certificate. So generate certificates for TLS registry. So that's what we will be doing now. So let me remove the Docker compose file, or -f docker compose. Okay, so the first version we tested, it's all working fine, no problem. And I'm also going to delete the my test deployment. Okay, so now we are going to enable SSL or TLS. So make dir certs. Okay, we've done that. And now I'm going to copy this and paste it in a file called openssl.conf. Okay, let's do that. Copy and vi openssl.conf. Paste that, and there are two things that you need to change: the common name. So this is my kind of boiler template, and if you want to change anything, that's basically the certificate that we are generating. Change your organization name, country name, locality name, whatever you want to change it. But the important thing is the common name. So I don't have a domain name or anything, so I'm just going to use my IP address 192.168.1.81, and again the alternate name, subject alternate name. Again here I'm going to paste my IP address 192.168.1.81. That's done. And finally I'm going to run this command openssl. It's a new request, x509 new key, and we're using 4096 bits, and we're generating the certificate which will be valid for like 1 year. We are passing in the config file, the one that we just generated, openssl.conf, and the key out. So that will be our private key, and that will be our certificate. All right, so copy that and paste it. Cool, that's that. And now if you look in the certs directory, we have the certificate and the key. All right, so we have the certificate and the key. Now if I go back to my Docker Compose file, I think we've got everything we need. All right, so we are going to use this Docker Compose file now. Move 02 to docker compose.yaml, docker compose up -d. All right, so now we are starting a Docker container with SSL TLS enabled, and it's again using the same Docker volume that we used in the previous container. So our image should be there, docker compose ps. Yep, so we've got the container running, docker images localhost :5000 my Debian. Cool, so still we have our image ready. All right, so that's it. So we've got the Docker container, the Docker registry that's running with TLS enabled. Let's do a quick testing to see if we can run our pod. kubectl get events. Okay, so kubectl run my test v1. Cool, so that's running. kubectl get all. Yep, our pod is running, no problem in pulling the image from actually I shouldn't be doing that. kubectl delete deploy successfully assigned pulled container image already present on the machine. Remember when we did this deployment earlier, it downloaded, it fetched the container image from my private Docker registry, so it's actually reusing that container image. So this time it didn't actually pull the image from my private Docker registry. So it says container image already present on the machine. So let's delete it. kubectl delete deploy my test. And now I'm going to say that always pull the container. kubectl run my test minus image index image dash pull dash policy is always. Okay, pulling image my Debian v1. So now it's pulling the image again from my private Docker registry, and it has successfully pulled the image. kubectl get all. Yep, so that's running fine, no problem. kubectl delete deploy my test. Cool. Okay, so what's next? I'm again going to terminate my Docker registry container, docker compose down, docker ps. All right, so we don't have anything. So now let's go and check out the authentication. How do you enable authentication in your private Docker registry? So if you look here, it's again an improvement to my previous Docker Compose file where we have SSL TLS enabled with these two options, environment variable. So now what I'm doing is I'm adding another 3 environment variable, registry auth. So we are using the HT password to generate a password file, registry auth HT password path. So where the actual password file is, so which is /auth HT password, and we are mounting ./auth into /auth inside the container. So what we are basically doing is we are going to generate a HT password file on our host machine and then mount that inside the container. And let's see how it all actually works. Okay. So which HT password? Do we have HT password? Yes. If you don't have HT password, just install Apache. So HT password comes with Apache, and I'm going to make a directory called auth. So we have this auth directory, and I'm going to create a new user and set a password so that that user with the password can log into our private Docker registry. HT password -bbn, and if you want to know what -bbn are, you can do help find that to less. So -b, use the password from the command line rather than prompting for it. -n is don't update the file display results on the std out. -uppercase B is to force the bcrypt encryption. Okay. HT password -b, lowercase b, n, and the user, let's say Docker compose or Docker user. Let's call the user Docker user, and the password is Docker password, or for simplicity let's call it test user, and the password is test password. So that's the file that will be that's the content that will be generated, and we need to redirect that to HT password file inside the auth directory. Let's do that. Just redirect that to auth HT password auth. Okay, so we have this HT password file which we are going to mount it inside the container, and the Docker registry will be using the /auth HT password, which is this file, for authentication. Okay, ls. So now we are going to use this Docker Compose file, which is basically shown here. I'm going to move that to docker compose.yaml. Okay, so docker compose up -d. All right, so it should be running docker compose ps. Yep, that's running in port 5000. Okay, so what should we do now? Let's say if we can pull the image, docker images, and I'm going to search for my Debian. Okay, I have this my Debian. I'm going to delete this image, docker rmi localhost :5000 my Debian v1. All right, so I've deleted that Docker image. Now let's see if I'm able to pull that Docker image. Docker pull localhost :5000 / my Debian v1. Yeah, so that's the problem. So since we enabled authentication in our private Docker registry, we need to log in first. Transport connection broken, malformed HTTP response. It's not a very useful error message, but if authentication is enabled, you need to pass in username and password, or you first need to do a Docker login to log into the Docker registry before you can actually pull or push your images. So Docker login localhost :5000. The username, what we did we create test user? I think we created test user, and the password is test password. Yep, cool. Login succeeded. So now we should be able to do Docker pull. Cool. So Docker images grep. So we've pulled the image. So we passed in the login details, username and password before we can pull the actual container image. So that's the testing we did on our local machine. So how about how would we do that inside a Kubernetes cluster? Okay, let's try that out. kubectl get events -w. So I don't need this browser anymore. Let's close that. -w. Okay, so we are watching the events that's going in the background. And now if I say kubectl run my test -image pull policy always, whether it's going to work. Let's see. Okay, so it's not working. It says the same error. Let's delete that. kubectl delete deploy my test, and you can see the error here, failed to pull image from our container, because we've enabled authentication but we haven't passed in the username and password to the Docker container, the Docker daemon. So what should we do now? Alright, so in order to access a in order to pull image from a password protected Docker registry, we need to create a secret first. kubectl create secret, and the type of secret is Docker registry, and give it a name my Docker credentials, and pass in --Docker server is 192.168.1.81:5000. --Docker username is test user, --Docker password is test password. Okay, so we've created the secret. If I do kubectl describe secret my Docker credentials, so we have that secret which is of type Docker config JSON. That's cool. So now we can't use that in the command line, so let's do a dry run to generate a YAML file, and then we can modify the YAML file to include the secret when pulling the container. So kubectl run my test, and basically I'm going to use this, but instead of actually deploying it, I'm going to use dry run -o YAML and redirect that to temp my debian.yaml. Okay, so if I edit that file my debian.yaml, so that's the file, and we don't need this strategy, we don't need resources, statuses. Okay, so now what I'm going to do is I'm going to add a option called pull image secrets, and the name is the name of the secret that we created, which is my Docker credentials. Yep, that's it. And if I watch the events now, if I run kubectl create -f temp my debian.yaml. So now we have passed in, we've created a secret that contains the Docker username, Docker server, Docker password, and then we've created a pod manifest. We've created a deployment manifest where we have specified the image where we are going to pull the image from, and we've also passed in the image pull secret, the secret that we created. So now it shouldn't have any problem in pulling the secret, pulling the container from our private Docker registry. Here validating pull image secret. Is that image pull secrets? Yeah, maybe vi temp my debian. I think it's image pull secrets. Let's change that to image pull secret. I don't know whether it's image pull secret or image pull secrets. Let's verify. Run that command, kubectl create. Hey, successfully created and successfully pulled the image. So now we don't see, previously we saw this error backing off, but now it has successfully pulled the image by passing in the Docker credentials to our private Docker registry, and it's all working fine. Kubectl get all. Yep, kubectl exec -it my test bash. It's all working great. Let's delete it. kubectl delete deploy my test. Cool. And let's also delete the container. So we've got docker volume ls, we've got that. Docker compose ps. Let's stop the container and also delete the volume. I'm just tidying up. Docker compose down, and if you pause -v, it will also delete the volume. See, removing volume docker registry, docker volume ls. Cool. That's all I wanted to show you in this video. Hope you found this useful. Please share and subscribe to my channel. If you've got any questions on this, please let me know in the comments. I should be able to help you. And thank you so much for your time watching this video. I will see you all in my next video. Bye-bye.